So hi everyone, now let's do a problem based on what we studied in the last class. Okay, that is we learned about the analysis of RL, RLC and RC circuits, right? So let's do a problem based on that. Okay, we'll be doing the problems using steady state condition and without using steady state conditions, okay, or applying initial conditions and without applying initial conditions. Okay, we'll be doing all the videos. We'll be covering all these portions. Okay, so let's do this a simple problem, that is one without having any steady state condition or without initial conditions on that. Okay, let's do a problem like that. So let's do this question. At time t is equal to 0, a unit pulse voltage of unit width is applied to a series RL circuit with R is equal to 1 ohm and L is equal to 1 Henry. Obtain the expression of the current I of t. So this is the question. Okay, so let's do this question. So here basically what we need to do is the first thing we need to do is understand the question and draw the diagram. So here the circuit is actually a series RL circuit, right? A series RL circuit with a switch. So let's draw that. A series RL circuit. So there is a voltage over here. That voltage is V of t, and this is the circuit diagram. Okay, so this is the circuit diagram. So this must be I of t, and what is the value of this resistor? 1 ohm. Okay, and what is the value of this inductor? It is 1 Henry. All right, so this is the circuit. Okay, so there. So this is the circuit diagram. Okay, so here they said that in this circuit a unit pulse voltage of unit width. So this is a pulse voltage. We all know how the pulse voltage is, right? A pulse voltage means it will be a rectangular in shape, and at what time it is being applied is applied at time t is equal to 0. So at time t is equal to 0, this is the pulse voltage, this is V of t, and this is x-axis is t. This is the signal. Okay, what is the width of this, or the duration of this? The duration is 1, right? Unit width. So the width is 1 second. And what about the height? It says a unit pulse voltage. A unit pulse voltage means the amplitude is also 1. So the height is 1, the duration or the width is also 1 volt and 1 second. Okay, so this is the voltage that is going to apply in this circuit. Okay, and now what is the question is, obtain the expression of the current I of t. That is, you need to find the value of I of t. That is the question. Okay, so the first thing that you do here is that you apply the Laplace transform to the circuit, or you find the transformed impedance of this circuit. Okay, so to find the transformed impedance, we need to know when is the switch is being closed or not. Here they said that at time t is equal to 0, a unit pulse of unit width is applied, right? So at time t is equal to 0, so that means what does it mean that at time before 0, what happens at that time? At that time nothing is being applied. That is, the switch is open at before time t is equal to 0. So if the switch is open before time t is equal to 0, that it means that there is no voltage applied. The switch is open. If it is an open circuit, no current can flow over here, because this circuit is not connected to the voltage. No current will flow through here. So therefore the current through this will be 0. So in that case, then the initial current across the inductor is also equal to 0. You see, so therefore the transformed impedance of the circuit is I can simply say transformed circuit. Okay, is this one. The switch is closed with a resistor and an inductor. Okay, and the resistor is 1 ohm and the inductor is, you don't have to write, just simply write 1 itself, because this is the transformed impedance. So the resistor is, the impedance over here is 1, and what about the impedance across the inductor? The impedance across the inductor, it is supposed to be LS, right? LS, but here L is equal to 1 Henry, so it is 1S or simply S. So S. Okay, So the impedance across the resistor is 1, the impedance across the inductor is S, and the voltage source is given by V of S, okay, and the current across it is called as I of S, capital letter I of S, where V of S is the Laplace transform of V of t and I of S is the Laplace transform of I of t, okay. So now let's write the Kirchhoff's voltage law equation of the circuit. And circuit is very easy, right? The equation is, that is I of S into 1 plus S, 1 plus S, or S plus 1. We should write S plus 1 because that is how our Laplace equations are all written like that, right? S plus 1. Anyway, into V of S, okay? Or in other words, I of S is equal to V of S by S plus 1. So this is the Laplace transform equation of the current, okay. But here we need to know what is V of S, right? So now that is our next step. So the first step what we did is we applied the transform impedance to the circuit. The second step is we wrote the equation of the current that we need to find the Laplace transform of it. Then the next step is you need to find the value of V of S, okay. So if you want to know the value of V of S, you need to know the equation for V of t. And what is the equation for V of t? You can see over here, it's very easy, right? The equation of V of t, what is this? This is a pulse signal. What is the equation of a pulse signal? And its duration is also 1 second, right? So which means the equation is, that is V of t is equal to U of t minus U of t minus 1. This is the equation for V of t, right? How did I get this equation? If you all remember the last video, I have explained it. See, how do you get the equation of the pulse signal? In this pulse signal, this is U of t, right? This is U of t at time t, and what is U of t minus 1? This is U of t minus 1. It starts from here, okay? This is U of t minus 1 after 1 second. That is U of t minus 1 means it is U of t which starts after delay of 1 second. That is the meaning of U of t minus 1, okay. So if you subtract these two graphs, what do you get? That is, from here to here, it is 1 minus 0, because the value of U of t minus 1 from 0 to 1 is 0. The value of U of t from 0 to 1 is 1 itself. So 1 minus 0 is 1. That is what you see here, okay. And from 1 to infinity, U of t is equal to 1. And from 1 to infinity, U of t minus 1 is also equal to 1. So 1 minus 1 is equal to 0. That's what, if you subtract these two graphs, you will get this pulse. That is the meaning of this equation, okay. So in that case, I can now say what is V of S. So V of S is nothing but the Laplace transform of this. That is, what is the Laplace transform of U of t? It is 1 by S. And what is the Laplace transform of U of t minus 1? It is nothing but U of t minus 1. So you are going to apply the time shifting property, right? That is nothing but e raised to minus S by S, okay. This is by applying the time shifting property. Okay, that is, we apply find the Laplace transform of the original signal and then multiply it with an exponential function, and the value of the is supposed to be e raised to minus as, but here the value of a is equal to 1, so it is e raised to minus s by s. Okay, or in other words, I can say equation 1 minus e raised to minus s by s. This is the equation of V of s. Okay, so now we found out that. So now I can substitute that over here. So therefore, I of s is equal to 1 minus e raised to minus s by s into s plus 1. Okay, and now you need to find the Laplace inverse of this. Okay, this can also be written as 1 by s into s plus 1 minus e raised to minus s by s into s plus 1. Okay, or this can also be written as 1 by s into s plus 1 minus e raised to minus s into 1 by s into s plus 1. Okay, this is the equation for I of s. Okay, so now in order to find your answer, you need to find this value I of t. All you need to do is simply find the Laplace inverse of this, or in other words, I of t is equal to the Laplace inverse of 1 by s into s plus 1 minus the Laplace inverse of e raised to minus s into 1 by s into s plus 1. Okay. So this is how we find the Laplace inverse. So to find the Laplace inverse, okay, this is how we find the value of I of t. So to find the Laplace inverse, you need to find the Laplace inverse of this, and you need to find the Laplace inverse of this. Okay, so how do you find the Laplace inverse of this? Using partial fraction method. Okay, and how do you find the Laplace inverse of this? Again, also you need to find the Laplace inverse you need to apply the partial fraction method. But here the thing is, after finding the Laplace inverse of this factor, then you apply the time shifting property, because it is being multiplied with e raised to minus s. Okay, so here first you find the Laplace inverse and using partial fraction method, and then you apply the time shifting property in order to find the inverse of this entire term over here. Okay, but lucky for us, the same factor is also written over here, which means you just need to find the Laplace inverse of this term only because both of them have the same factor. See, 1 by s into s plus 1, 1 by s into s plus 1. So you need to find only the Laplace inverse of this. Okay, and that same answer goes over here also, and then over here then you apply the time shifting property. Okay, that's all. So let's find. So I'm going to find the Laplace inverse of this. Okay, so to find the Laplace inverse of this, I'm going to partially factorize this, which means I'm going to change 1 by s into s plus 1. I'm going to change it into a by s plus b by s plus 1. This is how I'm going to change it. So which means I need to find the value of a and b. So what is the value of a? What is the value of b? See, this is how we partially factorize. That is, if there are two separate individual independent factors, then we separate that into two terms. How many factors are there? That many terms should be over here. Okay. So here it is a by s plus b by s plus 1. So here we need to find first I'll find the value of a. So how to find the value of a? I'll give you a shortcut method. Okay, only in this problem I'll give you how to do it. In the rest of the problem you need to learn to do it by yourself. Okay, so how do you do it is, to find the value of a, you simply look at the denominator of a. The denominator of a is this factor s. So what you do is you remove that denominator from the main equation. Just simply remove it. Okay, or assume it's not there. Remove it. So what is remaining? 1 by s plus 1 is remaining. Okay, and then what you do is you substitute the value of s as per your denominator equation. That is, you equate the denominator to 0 and find the value of s. So what happens if I equate this s to 0? The equation will become x is equal to 0, which means s is equal to 0, which means in order to find the value of a, you simply substitute s is equal to 0 over here. This is the value of a. Okay, that is, first to find the value of any coefficient, first you look at the denominator, remove that same factor from here. Okay, remove the same factor from here, and then write the remaining terms over here, and then substitute the value of s as per the equation from the denominator. So therefore you will get s is equal to 0. So this is nothing but 1 by 0 plus 1, right? 1 by 0 plus 1, which is equal to 1. Likewise, to find the value of b, alright? To find the value of b, look at the denominator of b. It is s plus 1 is the denominator, right? So which means I remove s plus 1 from here and write the remaining terms. Remaining terms is only this much, right? 1 by s. And then what is the denominator equation? It is s plus 1 is equal to 0. If s plus 1 is equal to 0, then what is the value of s? Value of s is minus 1. So substitute the value of s as minus 1 over here. Okay, so you will get 1 by minus 1, which is equal to minus 1. Therefore, the value of a is 1, the value of b is minus 1. This is the shortcut method. If you are finding this method difficult, then you can go for the long cut, which you are in that case you should be really fast to do the problems. That is simply taking the LCM. Okay, simply taking the LCM. That is another method. The second method is simply taking the LCM. In that case, the equation will become 1 is equal to a into s plus 1 plus b into s. This is the equation. Okay, and then what you do is you substitute the value of a and and after doing this equation you expand it, so you will get a into s plus a plus b into s, or in other words I can say that it is equation s into a plus b plus a. Let me see, s into a plus b plus a. Okay, S into A plus B plus A. This is the equation. Alright. So in that case, then what you do is you simply compare the coefficients of S. So what is the coefficients of S? So which means here the coefficient or every coefficients of S. Okay. So here in this case, here for S raised to 1, the coefficient is A plus B. Okay. And what is the coefficient of S over here? There is no S over here, which means the coefficient of S over here is 0, which means A plus B is equal to 0. Okay. Now what is the coefficient for S raised to 0? The coefficient of S raised to 0 is 1, right? So the coefficient of S raised to 0 over here is 1. The coefficient of S raised to 0 over here is A. If you compare these two equations, which means that A is equal to 1. So therefore, if A is equal to 1, then what is the value of B? Therefore, B is equal to minus 1. See, this is another way of finding the value of A and B. Okay, you can apply any two methods. Okay, so in that case, I have found that that 1 by S into S plus 1 is equal to, the value of A is 1, so 1 by S, and the value of B is minus 1 by S plus 1. Okay, so therefore the Laplace inverse of 1 by S into S plus 1, okay, is equal to the Laplace inverse of 1 by S minus the Laplace inverse of 1 by S plus 1, and we know what is the Laplace inverse of 1 by S, which is nothing but U of t, and we also know the Laplace inverse of 1 by S plus 1, it is nothing but e raised to minus t into U of t. Okay, like I said, here there's extra U of t over here to show you that this is a unilateral Laplace transform. It is from 0 to infinity. U of t is only from 0 to infinity. The value of U of t before 0 is nothing but 0 itself. That is why I am written e of minus t into U of t. Okay, this is the equation. Or in other words, I can also say it is nothing but 1 minus e raised to minus t into U of t. That is your preference. Okay, you can write either like this or like this, whichever method you choose. So this is the Laplace inverse of this. If this is the Laplace inverse of this, then the Laplace inverse of e raised to minus t into 1 by S into S plus 1 is nothing but, all you need to do is simply apply the time shifting property to this value. And what should be the value of the time shift? It should be minus 1, right? Because the minus a over here is minus 1. So therefore the time shifting should be applied to minus 1. So replace every t with t minus 1. That's all. Replace every t with t minus 1. Or just for your convenience, I will write like this. Okay. Let me write like this, just so that you will understand what I have written over here. At t minus 1, that is, replace every t here with t minus 1. So you will get 1 minus e raised to minus of t minus 1 into u of t minus 1. Okay, this is the value. So therefore I of t is equal to, like I said, I of t is equal to the Laplace inverse of 1 by S into S plus 1 minus the Laplace inverse of e raised to minus t into 1 by S into S plus 1. Okay, so therefore it is equal to 1 minus e raised to minus t into u of t, okay, minus again 1 minus e raised to minus of t minus 1 into u of t minus 1. This is the equation of I of t. Okay, so this is how we do the problem. Okay, that is, let me recall, this is how we do for all the problems. First you understand the circuit, you find its transfer impedance, okay, and then after finding the transfer impedance, you write the equation of the current involved in that. Okay, whichever the current across which element they are asking across that. So here they are asking the current across I of t. I of t is the current over here. So you find, suppose if they ask you the voltage across the inductor or voltage across the resistor, then again you need to find the current, and then you simply need to multiply that current with the impedance. Okay, So anyway, here they have asked only the current, so I'll find the current. After finding the equation of the current, I substitute the value of V of S, that is the Laplace transform of the voltage. So to find that, I need to know what is V of t. After finding out what is V of t, I find V of S, and after finding V of S, I substitute that over here in I of S, and then I find the value of the I of t by using the partial fraction method. Okay, and after finding the partial fraction, after finding the value of I of t, that's your answer. Okay, that's it. This is the steps. Likewise, now let's do the next question. Okay, so I hope all of you did understood this, right? Now let's do the next question. This is the next question, that is a rectangular voltage pulse of unit height and t is equal to 0. Rectangular voltage of unit height and t seconds duration is applied to a low pass RC circuit at t is equal to 0. Obtain the expression of the voltage across the capacitor. This is the question. Okay, so here again we are applying a pulse voltage. Okay, and this time the circuit is a low pass RC circuit. It's a low pass RC circuit. So let's draw the circuit. A low pass RC circuit, we all know, right, how the circuit looks like. And time t is equal to 0, which means there is a switch. Okay, low pass RC circuit means it looks like this, right? This is the circuit for the low pass RC circuit, and then you have the voltage over here. It's called V of t. Okay, this is V of t. And what is the value of the resistor and capacitor over here? There is no values given, right? There is no values given for resistor, so I will substitute this as R, and I will substitute this as C. Okay, as usual. And now obtain the expression of the voltage across the capacitor. That is the question. So to know the voltage across the capacitor, I need to find the current across the capacitor, and the current across the capacitor is I of t. So first I need to find the I of t, then you multiply that with the impedance. Okay, so here at time t is equal to 0, right? And what is being applied? A rectangular voltage pulse of unit height and t seconds duration. That is, again we have a pulse as usual. Again we have a pulse, and here is applied at time t is equal to 0. So at time t is equal to 0, a pulse is being applied. So in that case, I need to know the duration and the amplitude. What is the amplitude? They said a rectangular voltage pulse of unit height. A unit height means the height is 1 volt. Okay, the height is 1. Now, and t seconds duration, which means the duration or the width is actually capital letter T. Okay, this is the question. This is the V of t. Okay, it's applied to a low pass RC circuit at time t is equal to 0. So that means at time t is equal to 0, the switch is closed, right? If time t is equal to 0, the switch is closed, then which means at time before time t is equal to 0, the switch was open. If the switch is open, then that means no current will flow through here. Therefore, the initial voltage across the capacitors will be 0 itself, right? It's understood. They have not mentioned anything about the steady state condition or about the initial condition. So therefore, you can say that the initial voltage across the capacitor is 0. Okay. If they have not mentioned anything about the initial conditions, then you can assume that it is the initial conditions are 0. Okay. So now all I need to do is simply apply the transformed impedance of the circuit. Therefore, so how the circuit looks like, right? That is, you first draw the voltage, and its Laplace transform as V of S. Then you have a resistor, sorry, it should be a resistor with a capacitor. Okay, and there is no voltage source over here, right? Because the initial condition is 0, so there is no positive voltage over here. This is the circuit, the resistor, the Laplace transform of a resistor is R, the Laplace transform of a capacitor is 1 by Cs. Okay, here the value of R and C is not given, so I'm using that same value as it is, R and C. Okay, now V of S, this is the V of S is the Laplace transform of V of t, and I of S is the Laplace transform of I of t. So now I'm going to write the equation of I of S as usual, right? Where we're applying the Kirchhoff's voltage law. So according to the circuit, I of S into what are the impedances? R and 1 by Cs. So R plus 1 by Cs is equal to V of S. Okay, this is the Kirchhoff's voltage law equation of the circuit, or the mesh equation, right? The mesh equation of the circuit. So here, maybe I write this in this format, that is I of S is equal to RCS plus 1 by Cs is equal to V of S. Okay, now you can write any way you want, that's your choice. And here in that case, the I of S is equal to V of S into Cs by RCS plus 1. Okay, but like I said, in all your Laplace transform formulas that you have studied, the denominator, if there is an S or S square anything, the coefficient is always 1, right? Here the coefficient is RC, so what I'll do, I'll take RC common, so it will become V of S into Cs by RC into S plus 1 by RC. Okay, the C and this C will cancel each other, so you will get V of S into S by R into S plus 1 by RC. V of S into S by R into S plus 1 by RC. Okay, so this is the current across the elements. So why did I find the current across the element? Here the question was obtain the expression of the voltage across a capacitor, because the reason is across any element, if you're trying to find the voltage or the current across any element, the first thing you need to do is to find the current across the element itself. First you find the current across the element, and then you multiply that current with its impedance. What is the impedance? So here they're saying obtain the expression of the voltage across the capacitor. So the voltage across the capacitor is nothing but the current across the capacitor into the impedance of the capacitor. The impedance of the capacitor is 1 by Cs. Okay, so therefore I can say that VC of S. Okay, let Vc of S be the Laplace transform of Vc of t, which is the Laplace transform of Vc of t, which is the voltage across the capacitor. So in that case, I can say that the voltage across the capacitor is I of S into 1 by Cs. This is the voltage across the capacitor, or in other words, it is V of S into S by R into S plus 1 by RC into 1 by Cs. Okay, this S and this S will cancel each other, and we have the equation as V of S by RC into S plus 1 by RC. Okay, we got this equation right here. So now the next step would be to find the value of V of S, because after finding the value of V of S only I can find the Laplace inverse of this, right? So I need to find the value of V of S. To find the value of V of S, I need to know the equation of V of t, and V of t is already given over here, and from here I can simply say that the equation for V of t is nothing but U of t minus U of t minus capital letter T. Okay, this is the equation, right? I want you all to understand how I got this equation, right? It is same like before. Okay, so you try to understand how I got this equation. So this is the equation for the pulse signal. Okay, always the pulse signal is represented as a difference between two step signals, two unit step signals. Okay, so this is the equation for V of t. If this is the equation of V of t, then I can say the equation for V of S is equal to 1 by S minus, and the equation over here is e raised to minus Ts by S. This is the Laplace this is the Laplace of U of t. This is the Laplace of U of t minus t. Okay, this is by applying the time shifting property. Okay, so in that case, this can also be written as 1 minus e raised to minus Ts by S. So I found the Laplace inverse. So therefore I can now say that Vc of S is equal to, I can substitute the value of V of S, right? This is the V of S, that is 1 minus e raised to minus Ts by is RC. So I write RC first into this S over here into S plus 1 by RC. Okay, this is the equation. Okay, I will take this 1 by RC outside over here. It's a constant, right? So no need to put that into our calculation. And this is equal to 1 minus e raised to minus Ts by S into S plus 1 by RC. Okay, this is the equation. So in that case, this can also be written as 1 by RC into, and here you have 1 by S into S plus 1 by RC minus e raised to minus Ts by S into S plus 1 by RC, which means if you want to find the Laplace inverse, you need to find the Laplace inverse of this, you need to find the Laplace inverse of this. So this is, therefore Vc of t is equal to 1 by RC into the Laplace inverse of 1 by S into S plus 1 by RC, okay, minus the Laplace inverse of e raised to minus Ts into 1 by S into S plus 1 by RC. Okay, so which means to find the Laplace inverse of this, in order to find the Laplace inverse of, in order to find Vc of t, first you need to find the Laplace inverse of this in the first term, and then in the second term you need to find the Laplace inverse of this value, and then add or then apply time shifting property to this value. But luckily over here both of them have the same factor. So which means all you need to do is simply find the Laplace inverse of this to find the Laplace inverse of the first term, and then apply the time shifting property to this term in order to find the Laplace inverse of the second term. That's all. So first I'll find the Laplace inverse of this. So that is, first I need to partially factorize this. So this becomes 1 by S into S plus 1 by RC. This is equal to A by S plus B by S plus 1 by RC. Okay, that is how many factors are there, that many terms should be there. Here there are two independent factors, so there should be two terms. Each of them have their own coefficients which you need to find. So find the value of A and find the value of B. So what is the value of A? The value of A is equal to S 1 by S by 1 by RC, and then you substitute S is equal to 0. Okay, this because if S is the factor of A, S is the denominator of A, right? S is the denominator. So remove S from here, write the remaining terms and substitute the value of S is equal to 0, and you will get RC, right? 1 by 0 plus 1 by RC is 1 by RC, which is RC itself. Next is B, and B is equal to, here the denominator of B is S plus 1 by RC. So remove S plus 1 by RC from here, only this much remains, and then substitute the value of S is equal to minus 1 by RC, and you will get minus RC. Okay, you will get minus RC. So I found the value of A, I found the value of B. So which means I can now say that 1 by S into S plus 1 by RC is equal to RC by S minus RC by S plus 1 by RC. You can also write this as RC into 1 by RC into 1 by, not like this, RC into 1 by S minus 1 by S plus 1 by RC. Okay, this is how we find. So therefore the Laplace inverse of this is 1 by S into S plus 1 by RC is equal to the RC into the Laplace inverse of 1 by S, okay, minus the Laplace inverse of 1 by s plus 1 by RC. Okay, this is equal to RC into, what is the Laplace inverse of 1 by s? It is u of t. What is the Laplace inverse of 1 by s plus 1 by RC? It is e raised to, frequency shifting property, e raised to minus t by RC, or minus 1 by RC into t, which is t by RC. Okay, into u of t. Right, this is the equation. Okay, this is the equation of this. So if this is the Laplace inverse of this, then in that case the Laplace inverse of what was the second term? This is the second term, e raised to minus ts, e raised to minus ts into 1 by s into s plus 1 by RC is nothing but the same thing, but replace t with t minus capital T, right? That is nothing but RC into u of t minus u of t minus e raised to minus t by RC into u of t again, at replacing t with t minus capital T. This is it. That is, we are simply finding the Laplace first. That's what I did. To find the second term, I need to find the Laplace inverse of this, then apply the time shifting property. That's exactly what I did over here. I already found the Laplace inverse of this, right? I already found the Laplace inverses. Now I need to apply the time shifting property to this equation. The time shifting, that is replacing t with t minus t. So therefore this is the answer. That is RC into u of t minus capital T minus e raised to minus of t minus t by RC into u of t minus t. This is the Laplace inverse of this. So therefore I of t is equal to RC, and RC is 1 by RC, 1 by RC, right? It's 1 by RC. Yeah, here it's 1 by RC, 1 by RC into, and what is the Laplace inverse of this? Is this, that is RC into u of t minus e raised to minus t by RC u of t. Okay, this is the Laplace inverse of the first term minus the Laplace inverse of the second term. This is the Laplace inverse of the second term. So therefore minus again RC into u of t minus t minus e raised to minus t minus t by RC, okay, into u of t minus t. Okay. So here if you take RC common, then the RC and RC will cancel each other. So you will be left with u of t minus e raised to minus t by RC u of t, and that's one thing. And over here it will become minus of, and here it will become u of t minus t minus e raised to minus of t minus t by RC u of t minus t. Okay, and in that case the answer is 1 minus e raised to minus t by RC into u of t minus 1 minus e raised to minus t minus t by RC into u of t minus capital T. This is the, not the current, this is the voltage across the capacitor. Okay, the voltage across the capacitor Vc of t. Okay, the voltage across the capacitor Vc of t. This is the answer. Okay, so this is how we do the problems. Every problem, the step is the same. Okay.